Did you know that heat waves are one of the deadliest natural disasters on Earth? They might not be as dramatic as hurricanes or earthquakes, but they kill more people, strain infrastructure, and are getting worse every year. In this video, we're diving into how a heat wave works, what causes it, and the different types you might not even know exist. Let's break it down. A heat wave is a prolonged period of unusually high temperatures for a given region. But here's the tricky part: there's no universal definition. In some places, a heat wave might mean 3 or more days above 90 degrees Fahrenheit. In others, it's defined relative to the average temperatures for that time of year. So, what qualifies as a heat wave in London might be considered normal in Dubai. Still, the common thread is extreme heat lasting multiple days, and often dangerously high nighttime temperatures too. Heat waves are typically caused by high-pressure systems in the atmosphere. These systems act like a giant lid over an area. They trap warm air near the surface and block cooler air from moving in. With clear skies and little wind, the sun heats the ground more than usual. Each day, the heat builds up more and more. In cities, this effect is even stronger due to the urban heat island phenomenon, where concrete and asphalt absorb and retain heat long after the sun goes down. That's why heat waves can be especially brutal in large urban areas. Now let's talk about the different types of heat waves. Yes, there's more than one kind, and each has its own characteristics and impacts. The first is the classical heat wave. This is the standard dry heat that most people think of: clear skies, high daytime temperatures, and low humidity. It's common in places like inland Europe or parts of the US Midwest. Next is the humid heat wave. This one combines high temperatures with high humidity, which makes it feel even hotter. This is because humidity prevents sweat from evaporating, which is your body's natural cooling mechanism. These are common in tropical regions and coastal areas like the southeastern United States or South Asia. There's also the marine heat wave. Yes, heat waves can happen in the ocean too. A marine heat wave is when ocean surface temperatures rise significantly above average for a prolonged period. These events can devastate marine ecosystems, bleaching coral reefs, killing fish, and altering weather patterns. Then there's the nocturnal heat wave. This occurs when nighttime temperatures remain unusually high, providing no relief from the day's heat. These are particularly dangerous because they prevent the body from recovering overnight, increasing the risk of heat-related illnesses. Finally, we have the flash heat wave. These are short-lived but intense spikes in temperature. They often come on suddenly and can catch people off guard, leading to power outages and health emergencies in just a matter of days. Heat waves are silent killers. They can cause dehydration, heat exhaustion, and heat stroke, especially in vulnerable populations like the elderly, children, and those with pre-existing conditions. They also put extreme pressure on power grids, often leading to blackouts just when people need cooling the most. Food production can suffer too, as crops fail under the stress of extreme heat and drought. And wildfires? They thrive in heat wave conditions, spreading faster and burning hotter. In 2003, a heat wave in Europe killed more than 70,000 people. And events like that are becoming more frequent. This isn't just a seasonal inconvenience, it's a growing global threat. Fortunately, heat waves can be predicted days or even weeks in advance. Meteorologists use satellite data, ocean temperatures, wind patterns, and pressure systems to track developing heat domes and other precursors. Early warning systems have improved significantly. Still, not everyone has access to air conditioning or safe shelters, so prediction alone isn't enough. We need solutions. To adapt to heat waves, cities can plant more trees, use reflective building materials, and improve emergency response systems. Cooling centers and public information campaigns can save lives. On a larger scale, reducing greenhouse gas emissions is essential to limiting future warming and, by extension, future heat waves. So now you know, heat waves aren't just about a few hot days. They're complex, dangerous, and increasingly common. From classical dry spells to marine and nighttime heat events, understanding them is the first step to protecting ourselves and our communities. If you learned something new, hit like and consider subscribing for more science content. Thanks for watching, and stay cool out there.